Hello again, my name is David Watts from Lenovo Press, and I have with me today Pat Moakley. He is the Director of Worldwide Marketing for Dense Systems. And today we're going to be talking about the new sd350, ThinkServer sd350, our new dense offering. Pat, tell us about this system and what sort of applications it's suited for.
So the sd350 and the N400 enclosure that you see here are part of a new form factor for Lenovo, a 2U4 node. 2U4 node systems have gained a lot of popularity with customers and with the hyper-converged industry. They like the dense packaging of the 4 compute nodes with the storage in close proximity. So as you can see here, there are 24 drives in the N400 enclosure, and there are strapped 6 drives per each compute node.
And also on the front of the enclosure, there are a number of buttons and LEDs for each of the servers. You can power off each server individually through the power button. The identity button allows you to identify which server is being worked on. A matching LED at the back will also light up when you press the button. You can control the identity button via software as well. And there's also a fault button as well for each of the systems. And in this package, the servers are at the back.
Yes.
We'll get to that in a moment. Yeah.
Servers are in the back, so this is what a customer would see in the rack in the front.
Yep. So now this is our new dense offering. We already have the next scale system offerings, the NX360
Yes.
M5. How does the sd350 compare to that?
So it's really in the applications. The sd350 supports the new E5 2600 processors up to 40 cores and 135 watts. So as I said before, it's very popular for hyper-converged solutions and for distributed enterprise. The NX360, or the next scale offering, supports the same processor, the E5 2600, but it supports up to 44 cores or 145 watts. It also supports a wide range of GPUs, so you get more high-performance computing customers migrating towards that, and more of the hyper-converged customers using the N400 and the sd350.
You mentioned hyper-converged. So is this system suitable for applications like Nutanix?
Yes, we are hoping to have a Nutanix offering on this box by the end of the year.
Okay, yeah. So that would be a great solution for customers looking for hyper-converged offerings.
Yes, it would allow customers, as you know, the Nutanix offerings will virtualize the storage across the nodes and pretty much eliminates the need for having a SAN, and then it saves the cost of the SAN itself and then the administration of it.
Yep. All right, very good. So let's spin this unit around and have a look at the servers, and we'll go from there. Okay, so we're looking at the back of the, this is the N400 enclosure. We're looking at the back of that, and you can see there are 4 servers, 2 at the top, 2 at the bottom. This is the 4-node part of the 2U4 node title. 2 power supplies drive the entire enclosure. But let's look first of all at each of the servers, shall we?
Okay.
Let me pop one of those out. It's a simple remove of the unit. No cover, as you can see. Okay, so the obvious thing is the 2 processors and the memory. Pat, tell us about those.
So again, as I said before, E5 2600 V4s, Broadwell processors. As you can see here, we have a unique heat sink that allows the airflow, which is going to go this way, through processor 2 to processor 1. Standard E5 memory, so it's 4 memory channels with 2 DIMMs per channel. The sd350 servers will support up to 512 gigs of memory per server.
And with the V4 processors, these memory DIMMs are 2400 megahertz, right?
That's correct. Up to 2400.
So 4 channels, 2 DIMMs per channel.
Yes.
Yeah. Okay. Total memory?
512 per server.
Yep. Okay. Very good. Now you noticed Pat said that the airflow runs in this direction. That's opposite to what our normal rack servers operate. So keep that in mind as we talk about it.
Yes.
At the front of the system are the I/O slots. The sd350 has support for 3 I/O slots. At the bottom is a MES card for network cards. That's using the OCP, or Open Compute Project form factor. This is a regular PCIe by 16, PCIe 3.0 by 16 slot, low profile. And then over here is another MES card for the RAID controller. So let's pull these apart. So let me first of all remove the this is the PCIe card. It's on a 1U riser. We support a variety of network cards, the 1 gig or 10 gig cards, or we offer a 40 gig InfiniBand offering as well from Mellanox. So it's currently Mellanox, Intel, and Emulex adapters are supported in this system.
Correct.
Yeah. This unit here, there's a black plastic shroud over the adapter. This is our RAID card. It's the H701L. It's a RAID card that supports RAID 0, 1, and 10. Two SAS ports, supports SAS and SATA connectors. You can see it's a MES card that connects there. And if I can just put that over there, Pat. Then this here is the OCP adapter, and let me remove that one as well. We've removed the screws in advance of this video just to make it a little bit easier to show you how to get the cards out, but these are all screwed down. This one is the Intel X 520 SFP 10 gig adapter. We also offer an i350 1 gig Ethernet based adapter as well. This is the OCP form factor, Open Compute Project form factor. Now, in terms of drive connectivity, the server supports the onboard PCH, onboard SATA connector. So this is routes directly to the platform controller hub in the Intel chipset, and that drives, this can drive the SATA drives that would be installed at the front of the enclosure, and that supports RAID 0, 1, 10, and 5. Alternatively, if you want hardware RAID, then this is what the H701L adapter, where that comes in. And you can see that the cabling of these, there's a cable that routes from the adapter through to the front, to the front of the server, to this connector here, and that goes through the end connector through to the drives. If you were to use the onboard SATA instead, there would be a different cable, slightly shorter, that would connect into this connector instead. So that's how the connections from the controllers to the drives are made. Now, there's these little blue connectors here. Pat, what are those for?
Glad you asked. Those are Sata Dom connectors, and Sata Dom is a new technology for us, the sd350. This is the Sata Dom card. It's similar to an SD card. This is a 64 gig card.
What does Sata Dom stand for?
Sata Dom is SATA, serial ATA. DOM stands for disk on module, and you simply plug it in just like an SD card, and that's for booting for hypervisors.
So it's seen by the operating system as a driver, as a device.
Yes.
Yeah. So it's another drive in addition to the 6 drives you have for the server.
But it plugs into the SATA bus.
Most useful for operating systems.
Yes.
Yep. Yep. Very good. All right.
As you can see, the sd350 is an extremely dense solution. We like to call it ultra dense, which means that each node, which is a half wide, takes up less than a U, right? In this case, the sd350 is a half U system. It's also managed by xClarity.
Right, yeah. So the support for xClarity is like the other ThinkServer systems we have. It supports the inventory management and alerting and monitoring and call home.
Right. Call home is very important for distributed enterprise environments.
Yep. Now, the server also has a dedicated RJ45, that's for systems management. If you want, you can use an OCP adapter for your systems management connection. You can share the port 1 of the adapter with the operating system and with systems management. If you didn't want to use the dedicated RJ45, at the front there's also the VGA port and 2 USB 3.0 ports. Okay, so that's the basics of the server. Now, if I can put this back here for a moment, let's now look at the rest of the enclosure. I'm going to put those to the side. Yeah, put them over there. Yeah. Okay, so as you mentioned at the start, the enclosure is the where the 4 servers plug into, and it supplies power and cooling to those servers. So the 2 power supplies at the front, we offer 2 1600 watt power supplies. These are enough power to supply all configurations,
yes,
fully loaded configurations. We also offer a 1200 watt power supply option too, right?
Right, for lower bin CPUs, lower memory configurations within the nodes.
Yeah.
You may be able to get by, save some money by going with the 1200.
Yeah, so
you probably want to default to the 1600 to begin with.
Yeah, right. Yep. Okay, so let's now remove these covers here. We've removed the screws again just to make it a little bit easier to show you what's inside here. These two covers reveal the fans. The fans, these are the cooling fans for the entire enclosure. We have 5 60mm easy swap fans. You can see from the blue color that these are not hot swap, so you would remove power to the enclosure before you remove the fans. But they are very easy to take out and replace if needed. They're a redundant set, so if one of them fails, the server will still operate as normal, allowing you to schedule downtime to remove that failed unit. Now this panel here is where the power connectors routed from the power supplies through to the circuit boards in the middle of the unit. And so you can see, if I look at the drive connections, the drives are at the front, and they connect to this. It looks like it's one backplane, but these are four discrete backplanes. The SAS connectors that go through to the mid-plane connectors, through the edge connector of the server, up to this connector, which then routes to the front of the server, to either to the RAID card or to the onboard SATA ports as well. And we didn't talk about the drives at the front, at the beginning of the video. What sort of drives are supported in this system?
Supports both SAS and SATA, up to 2 terabytes per drive, so it's 12 terabytes per server or 48 for the enclosure.
Right.
So,
so the 2.5-inch hot swap drives,
yep.
SAS or SATA, SSDs or hard drives.
Correct.
Yeah. All right. And this is a 6 gig SAS environment, so the controllers are 6 gig SAS or SATA drives, drive support. All right. So there you have it. This is the sd350 and N400 enclosure. This is our new dense offering. Hope you found the video useful. Pat, thanks so much for your time.
Thank you. Appreciate it.
And we'll see you later.